Hi everyone, welcome to this new video. Is over console setup and routers. I only read in I practice with Cisco Packet Tracer. Okay, and the first point is console setup. Your Cisco router has a port resembling a standard Ethernet RG45 port. Label console. You receive a console cable with your router. Plug one end into your router and attach the serial port to a 9-pin serial port on a computer. Now, you need serial port client software on your computer. We'll assume that you are using Hyperterminal for Windows to connect to the router. Hyperterminal is available on all versions of Windows. If you are using another operating system, it must have a serial port program available. Free Unix-like operating systems usually include TIP or CU and Kermit and Minicom are also available for many different operating systems. Specifics of configuring these programs vary, but the settings we use here will work for any of them. In modern Windows version, Hyperterminal may not be installed by default. If you look under Start, Program, Accessories, Communications, and don't see Hyperterminal, it's not yet installed on your system. Go to the Add Remote Programs control panel and select Windows Components. Hyperterminal is a part of a communications feature set. Once you have your serial client software installed, set up a new connection to your serial port. Use the following settings. Okay, and in my case I use Cisco Packet Tracer, and in the real life uh, we use PuTTY, how Hyperterminal, and this is the configuration. Is 9600 bound, no parity, 8 data bits, 1 stop bit, and no flow control. Click the connect icon. Because your router has no power yet, you should see anything happen. And other routers ports. The out port looks just like the console port, and you can even plug in your console cable and get a command line on your serial client. A router doesn't display its boot message on the aux port. However, for the most part, the aux port is there only in case something goes wrong. If you misconfigure your console port and find yourself locked out of the system, you can log in via the aux port and fix the router's configuration. In the event that you really bought an upgrade, you can set your aux port to use high-speed connection and upload a new software image to the router over it. You might connect a modem to your console port for working remotely and use the aux port for local work. Network interfaces look different from router to router, but for the most part, they have a connector appropriate to the type of network they connect. Ethernet interface usually have either a standard Cat5 or fiber connection, while TI interface look like Cat5 connectors. Larger circuits such as DS3s and OC3s have coaxial connections. Look at your router and identify the type of network interfaces it supports. You have need to how you have to need to know that later. Okay, power on. With your serial connection in the console port, plug in the router, and in a few seconds you have see some activity. Okay, in my case in Packet Tracer, go to network devices, routers, and I use the router 4331. Okay, power on. Okay, enter and quit. System bootstrap. Okay, is charging the system, and you see a variety of facts about the kitman, such as the bootloader version and the hardware platform. The system then starts loading the operating system and heads for the main boot sequence. We'll interpret most of this output later. Let the rover keep booting until it wants to talk to you. If this is the first boot, the rover will offer to let you configure it. Okay. Would you like to enter the initial configuration dialog? Okay. And the configuration dialog is designed to get the bare minimum system up on the network, allowing you to use a configuration tool such as Cisco Works to complete this setup. For reasons we'll discuss in the next chapter, I encourage you to perform all the configuration at the command line instead of by one of these tools. Once you read this book and understand the implication of your choice, you might want to use a configuration dialog to perform basic setup. For that reason, I recommend that you skip the configuration dialog. This will drop you to a router prompt. Okay. And no. Okay. Congratulations, you are now actually logged into router. Now let's see what you can do with it. Okay. And befriending the command line. This book focuses entirely on the command line. Why? Some Cisco routers include a web interface, others don't. Cisco sells advanced router management packets, but they require a complicated client environment that you might not have available when you really need it. You might only need to log into the router once a year or less. What are the changes that your desktop system with all the fancy management tools has undergone some drastic surgery in the meantime, and the router tools no longer work the way you expect. Personally, I detest trying to solve Windows problems when the router is down. The one environment available on every Cisco router is the command line. The command line gives you absolute control over every aspect of your router's behavior. Some configuration changes can only be realistically made at the command line. If your router loses its configuration, you need to use the command line to restore enough of its mind that your fancy tools can talk to it. So, if you must use the command line in dire circumstances, it's best that you learn enough to be comfortable there. And exec versus privileged exec mode. By default, when you first log into a Cisco router, you are in exec mode. You can execute basic diagnostic commands and look at things, but you cannot actually change configuration settings or view sensitive information. For example, in exec mode, you can see if an interface is receiving errors, and you can ping across a circuit to see if it is working, but you cannot reset the interfaces. In exec mode, the command prompt ends in a greater than sign. Okay, this is exec mode. And to change anything or to run some more instructive commands, you must use privileged exec mode, which is a super user or administrator security level protected by unique password. Privileged exec mode is usually called enable mode. In enable mode, you can configure the router in any way desired, reboot the router, or take any other actions possible in the software. To enter privileged exec mode, use the enable command. When you actually have a password set to access enable mode, the router will prompt for it when you try to enable. See password on page 97. Okay, for entering enable mode, only enter enable. Okay. In enable mode, the command prompt ends in a pound sign. The old method of Cisco access control was to give the standard EXEC password to all the technicians but restrict the enabled password to senior tech. Setting up discrete username is a better way to achieve a similar effect, but many older routers still only use unprivileged and enabled password, either because they haven't been updated or because that's all that they can support. There's nothing wrong with restricting the use of privilege mode in this way, especially in a small shop where only one or two people connect to the equipment. But if you had more people, you will probably want to set up separated users' name and allow individuals to be privileged or not. We see we see how to do this in chapter 9. Okay. Integrated help. Help might be too strong a word, but routers offer hints on commands, command syntax, and the features available in the router at that privilege level. Different versions of the Cisco IOS have different features, and it's not easy to identify them all. The simple way to see what commands are available is to ask the router. Once you have login, enter a single question mark at the command prompt. And with this command. Okay. My third router has four full screens of commands available from a single question mark. Many of these commands are completely irrelevant for a router that is providing basic internet capability. Such activities require only a very small but subset of Cisco features. Still, this can be helpful when you can't quite remember the name of a particular command. Okay, I enter this command. Okay, and okay, you can you can request hints about individual commands. Many actions require one or more words to complete, and Cisco's integrated help system will provide helpful reminders about syntax or required information upon request. For example, the show command is used to view system information. If you want to know what arguments a show command can take, ask the router by entering show. Okay. And show. Okay. Access expression. On some versions of the iOS, this output can go on four screens. If you notice that the first part of the command's name even use the first letter, you can narrow it down by giving what you remember of the command and a question mark. Okay, in this example, we show A in the scene. Okay, show in sync. Okay. AAA access list ARP. Okay. Note that on your next command line prompt, the router automatically prints the chunk of commands that you gave before the question mark. Okay. And the system knows that you want to type something that begins with show A and is trying to make it easy for you. One thing to remember is that hints on a particular command are only available in the mode in which the command is available. For example, the command begins with IP such as iproute are only available in enable mode. Entering IP in standard exec mode will generate an unrecognized command error. And the next point is command abbreviation. One interesting feature of the Cisco iOS is that it allows the user to abbreviate commands names to the shortest unique abbreviation for a word. For example, one common command we use again and again to view settings is show. If you ask your router for all the commands begin with the letter S, you get a whole list. Okay, S and okay. Note that only the command show begins with the letter SH. You can use the letter SH as an abbreviation for the full word show. The router is smart enough to know that you could possible be typing any other legitimate command that begins with those letters. In this particular case, the letter S is also especially marked to indicate that is an abbreviation for show. Apparently, Cisco thought that show was so commonly used that it makes sense to abbreviate it further. In this book, we will give commands in the text by their full forms. Example commands might be an abbreviation for if they are commonly used that way. And router configuration. Now that you are logged into and have a basic understanding of how to enter commands, let's set up the router. The show version command explains some basic facts about your router, such as software version, hardware type, and supported interfaces. Because the output is quite long, I won't include it all here, but we'll look at a few important snippets. Okay, I entered the command show version, show version. Okay, Cisco iOS. Okay, version. Okay, in my case, this is the version. Release software. Okay. Okay. Now, the second line gives you the hardware platform this iOS is meant for. Okay, this is the software version and its version number. If you contact Cisco for support, you must provide the version number and exact details about who built this software and when, the ROM version, and so on. While the Cisco will certainly want to see all of this information, if you call it for support, you can't do much with it by yourself. Okay. The uptime. Tell how long the rover has been running. 4 weeks, 4 days, 9 hours, and 53 minutes. And the next line explains why these lots went down. Okay, point one. Okay, I were up, uptime. Um, Show version software. Software code. Okay, here is my ROM. Router uptime is 12 minutes 18 seconds. Okay. And the next line explains why it last went down. A reload is a software-driven reboot, as we discussed in Chapter 5. When a coworker asks, "Are we having internet trouble?" it's not to be able to say, that the rover has been working all along. The system image file. Okay. In this listing, okay, is the point 3 is here. In this listing is the location and name of the file that the rover loads as its operating system. This information will be important when the time comes to upgrade your iOS. The model information and physical characteristic of the rover shown below the system image file. Okay, flash. Where is uh, system returned to run my power? Okay, system image file. Okay, and point 4 can be important if your rover is in a remote office. Looking at this information may be the easy way to learn what sort of equipment it is. It would have been even easier for you to document the rover before sending it to the remote location. But despite our best effort generally, it's standard practice to use ship in and forget. After a few more lines that detail software features, we see the interface types installed in the router. The router will then list some model description for components and end with the configuration register. Okay, that is the point 7. Fast Ethernet, serial network, configuration register. Okay. Uh, these products contain cryptographic features and is subject to United States and local. Okay, more. Okay, if you require further assistance, please contact us by. Okay, suites. Okay, technology packet license information, reboot. Okay. Okay. Running versus startup. A rover has two configurations at any given time: the startup configuration and the running configuration. The startup configuration is stored in the rover's non-volatile memory. When the rover boots, it loads the startup configuration as the current configuration. At that point, a copy of the startup configuration becomes the running configuration. If you change the router's configuration while it's running, you are changing the running configuration. When you save the running configuration, it overwrites the previous startup configuration and becomes the new startup configuration. If you do not save your changes before you reboot the router, the changes are lost. Note: this is a long-winded way of saying save your changes or you lose them at the next reboot. Changing a router configuration is no different than editing a document in a word processor. If you exist without saving, you lose your work. This can be good or bad. Don't be afraid to use this to your advantage if you really screw up your router's configuration. Technically, you could say that the startup configuration is a configuration file. It's stored in non-volatile RAM, just like a file on disk. Cisco experts don't generally refer to the startup configuration as a configuration file. However, it's just a configuration. The running configuration is certainly not a file. It's a possible modified copy of the startup configuration held in memory. Startup configuration. To view the configuration the rover will boot with, enter the show startup config command. Okay. enter the show star config. So the config is not present. Okay. Startup config. The router reads the configuration for permanent storage and tells you how much space it takes up before displaying the command proper. Running configuration. To view the current running configuration, enter the command show running config. All Cisco users might remember this await terminal or WRTI. There's nothing inherent evil about WRTI, but it's considered obsolete. Okay. Running configuration show running configuration show. Okay. In the case of show startup config is not present. And show running config, building configuration, current configuration, 646 bytes, version 16.64, no service, timestamp block, the time, okay. Hostname router, IPsec, no IPv6 sef. And more expanding tree mode, okay. Version and more. Okay, and note the first line of the output where the routers tell you that it is literally assembling the current configuration from the router's memory. It then reminds you that this is the configuration in memory at the moment, which might or might not match what is in NVRAM. It then displays the configuration one screen at a time. Reading a configuration. We won't dissect a single complete router configuration in this book because a working configuration for even a small router can easily reach up to 200 lines. You should to read this configuration through. A Cisco IS configuration consists of a series of statements. Each statement either activates or deactivates a feature for an interface, a protocol, or the router as a whole, or defines some global characteristic of the router. You also see exclamation points, which IOs use to separate sections of a configuration. Okay, that's the character. Okay. Separate section. Okay. If you store copies of your router configuration in a place other than on the router, you can use exclamation points to indicate comments, much as many programs' configuration files use the point sign. The router will strip out these comments when loading the configuration, so very few people bother with them. For example, here are some snippets of a small router's configuration file. Okay. These routers support the network service timestamp, debug, and uptime. Their presence in the configuration file is enough to enable them. We also have a global configuration variable, the router's hostname. If the router thinks that configuration sections are sufficiently different, it puts a blank line between them. Okay. Service timestamp, debug uptime, and hostname router Black helicopters. Okay. If the rover thinks that configuration sections are sufficiently different, it puts a blank line between them. IP subnet 0, IP domain name, no IP finger. This router has two settings for Internet Protocol IP. The subnet 0 features is enabled, and the IP domain name is set. Conversely, the no settings disable a particular service. In this case, the finger service is turning off. Okay. I need translate this only. Okay, interfaces serial 1 Here we have a configuration for a particular router interface. Configuration information for this interface appears directly beneath it and has a single space in front of it. And note that we specifically turning off a particular feature here, IP redirects. Okay. Description main office T1. We call enable these features on the router as a wall and then disable it on an interface by interface basis or basis. Okay. Well, similarly, major routing protocols configured on the router each have their own section. Configuration for a protocol appears directly beneath each set of violating space. Okay. And finish with configuring the router. When you are in privileged EXEC mode, you can not only issue more powerful commands, but also change the router's configuration. To change the router configuration, you must enter the configured mode. The most common way to configure the router is at the command line you are logged in at, also known as the terminal. Enter configure terminal at the privilege mode prompt. Okay, for entering a privilege exit mode or config terminal. Okay, is conf terminal. Enter. And note that the command prompt has changed from simply router to router config. The router is making it explicit that you are configuring the system. At the configuring prompt, you can enter configuration statements, one statement per line. Configuration commands look exactly like those in the system configuration and are added directly to the router's configuration. For example, to add the line service password encryption to your configuration, just enter it at the configure prompt. Okay, and I enter well. First enter this command. Okay, configure commands. Show me all commands. Okay. Modify SNMP engine parameters. And IP. Okay. Access list. Save default gateway. Routing IP. Okay. Service password encryption. The router will place this in an appropriate spot in the global configuration. No, you can't put the statement in a place of your own choice in the configuration. The router knows far better than you do where each line belongs and will bluntly ignore any attempts to reorder the configuration. Entering a command line reload or ping at the configuration prompt will only generate an error because these are not legitimate configuration statements. When you have completed your configuration, leave configuration mode with Ctrl C. Okay, only one moment. Okay, exit of this. Only Ctrl C. Okay, enable mode. And this is for the next one. See you later.